Good morning, children. Today's class is on Chapter 7, Cubes and Cube Roots. The last lesson was on squares and square roots, and this lesson is on cubes and cube roots. How do you find the square of a number is by multiplying the number by itself twice. That is, the square number for 1 is 1 into 1, 1, and 2 is 2 into 2, 4, and so on. And we call the numbers 1, 4, etc. as square numbers or perfect squares. If you relate the same way with numbers, what our cube numbers or perfect cubes are, the number obtained by multiplying a number 3 times. That is, 1 into 1 into 1 is equal to 1 cubed is equal to 1. 2 into 2 into 2 is equal to 2 cubed is equal to 8. 3 into 3 into 3 is equal to 3 3s are 9. 9 into 3, 27. 5 cubed. 5 into 5 into 5 is equal to 5 into 5, 25 into 5 is equal to 125 and so on. That is, if you multiply any number 3 times by itself, the product or the answer you are getting will be called as a cube number or a perfect cube or a perfect cube. Thus, the general form you gave for a perfect square as any number m can be called as a perfect square if m is the product of n square, where n is any natural number. Similarly, the cube number can the same way said as m is equal to n cubed, where n is any natural number. Word cube is familiar to you and in another branch of maths where you were dealing with solids. A cube is a solid, it's a 3-dimensional solid which is having a length, breadth and height. A cube has length also A, breadth also A and height also A, because a cube has 6 square faces and so all the 12 edges are of length A units. That is, all the edges will have equal units. There, when you were asked to find out the volume of a cube, you were using the concept of A into A, which is the same as A cubed, cubic units. So the word is familiar to you as a cube, the example of ice cube, the dice you are playing with and so on. But the cube of a number is the product of a number multiplied by itself 3 times. Let us take the cube of numbers from 1 to 10. 1 cubed is equal to 1. 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, 5 cubed is equal to 125, 6 cubed is equal to 216, 7 cubed is equal to 343, 8 cubed is equal to 512, 9 cubed is equal to 729 and 10 cubed is equal to 1000. If you see the cube numbers, the units place of the cube numbers are all digits from 0 to 9 for different numbers. Then, another interesting fact is, if you count the number of cube numbers below 1000, it's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers below 1000, because as you multiply 3 times, the numbers are getting larger very easily. So the concept is, there are only 10 cube numbers below 1000. Whereas if you take the example of square numbers, there may be many numbers below 1000. If you check the cube of odd number, what is 1 cubed? 1. The next odd number is 3. What is 3 cubed? 27. 5 cubed, 7 cubed and 9 cubed. The cube of odd numbers are all odd, whereas the cube of even numbers are all even. So you can take it as cubes of even numbers are even and cubes of odd numbers are odd. Consider these numbers: 1729, 86, 333, 101 and so on. If you are asked to find out the cube of these numbers, you can easily predict the units place of the cube number. Suppose you are asked to find out the cube of this number, definitely the units place will be 9 cubed, that is 9 nines are 81, into 9, 729. So the units place will be definitely digit 9. If 86 cubed has to be found out, 6 cubed is 216, and so the units place will be 6. If you are asked to find out cube of 333, 3 cubed is 27, and so the units place will be 7. 101 cubed, the units place, 1 cubed is 1, that means the cube number also will have the units place 1. A square number had many interesting patterns, but for a cube number there are only 2 interesting patterns here. The first one is addition of odd numbers. Addition of odd numbers. The first odd number is 1. 1 can also be written as 1 and it is 1 cubed. What are the next 2 odd numbers? It is 3 plus 5. What is the sum of 3 and 5? It is 8. Is 8 a cube number? Yes. 8 can be written as 2 into 2 into 2, or it is 2 cubed. What are the next 3 odd numbers? 1, 3, 5. Next 3 are 7 plus 9 plus 11. If you take the total, 11 plus 9, 20. 20 plus 7 is 27. Again, it is a cube number, 3 into 3 into 3. What are the next 4 odd numbers? After 11, 13, 15, 17, 19. Is there any guess? Yes, it is 4 cubed, or the total is 19 plus 17. 10 plus 10, 20, 29, 36, 36, 46, 56 plus 8, 64. It's the same as 4 cubed. That is, what is the interesting pattern you have seen here is, for 1 cubed, you need only one number, one odd number. For 2 cubed, you need the sum of 2 odd numbers, but the order is not from the beginning. It should be in a series. 3 cubed will have the addition of 3 odd numbers. 4 cubed will have the addition of 4 odd numbers, but it's very, very important that the odd numbers are not starting from the beginning. So in that case, you can only tell about how many numbers, odd numbers, how many odd numbers are added to form number 1, 10 cubed, number 2, 12 cubed, number 3, 30 cubed, and so on. The only how many odd numbers you can predict very easily as 10 cubed. There should be 10 odd numbers. It will be the sum of 10 odd numbers. This will be the sum of 12 odd numbers, and this is the sum of 30 odd numbers, but the odd numbers will not be from the beginning of 1, 3, 5, etc. It should be a continuation of the series from 1, 3 plus 5, 7 plus 9 plus 11, and so on. The second pattern is when a perfect cube number is given to you. If you check the prime factorization, you can see that the prime factors occurs in triples. That is, each prime factor will occur 3 times. Let us check the cube number of 729, and it should be with the prime factorization. The prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43 and 47. If you can learn these numbers by heart, it is good because prime numbers below 50 are applicable throughout. 729, 7 plus 2, 9 plus 9 is 18. It is the divisible by 3. 3 2s are 6, 4 3s are 12, 243. Again, 4 plus 2 6, 6 plus 3 9, divisible by 3. It is 81 divided by 3, again 27 by 3, 9 by 3, 3 and 1. That is 729 can be written as 3 cubed into, if you group the prime factors as triples, if all the prime factors are occurring as triples, which shows that the number is a perfect cube. Thus, the property is any cube number can be expressed as the product of prime factors, but the prime factors should occur in triples. Exercise 7.1. Question number 1. Which of the following are not perfect cubes? The first question is 216. The method is express it as the product of prime factors. 216 by 2 is 108, by 2 54, by 2 is 27, by 3 9, 3 3 1. That is 216 is the product of 2 cubed into 3 cubed. Therefore, 216 is a perfect cube since all factors can be grouped in triples. The next example is 128. The prime factorization by 264, 32, 16, 8. If you group the factors 3 times, you can see that one of the factor 2 is occurring only once. So 128 is equal to 2 cubed into 2 cubed into 2, since the prime factors are not in triples, 128 is not a perfect cube. You can take more examples from page 112 in your textbook as question which of the following are perfect cubes and which of the following numbers are not perfect cubes from exercise 7.1 for practicing this type of questions. Type 2 and type 3 question, find the smallest number by which the number should be multiplied, and type 3 is number should be divided. Let's take one example from the textbook. The first question is multiplied 243. Find the least number by which 243 should be multiplied, which means that 243 is not a perfect cube. 243 divided by 3 is 81, divided by 3 is 27, by 3 9, by 3 3 1. So the factor 3 has come 3 times here. The second factor 3 has occurred only twice. We have to get one more prime factor 3, or 243 should be multiplied by 3. 243 should be multiplied by 3 to make it a perfect cube. And what is the perfect cube number? 243 into 3, 3 3s are 9, 4 3s are 12, 729. That is 729 is a cube number. Similarly, one more example I will show you with 675. Second example of 675. With 5 1s are 5, 5 3s are 15, 135. With 5 2s are 10, 27. Again by 3, 9, by 3, 3, 1. The factor 3 has occurred thrice, but the factor 5 has occurred only 2 times. Therefore, 675 should be multiplied by 5. Multiplied by 5 to make the number a perfect cube. And what is the number? 675 into 5, 3375 is a cube number. A similar pattern for divided. The first example in the textbook is find the least number. 81 has to be divided with. 81 divided by 3, 3 2s are 6, 27, by 3, 9, by 3, 1. That is, this 3 has occurred thrice, this 2 has occurred only once. 81 should be divided by 3 to make it a perfect cube. And what is the perfect cube number? 81 divided by 3 is 27. I hope you understood how to do it. You can continue the problems in the exercise on your own. As an extra question of this pattern, find the least number to be multiplied with 768 to make it a perfect cube. The procedure as normal prime factorization. By 2, 3 2s are 6, 8 and 4 divided by 2. 192 by 2 it is 96, by 2 48, by 2 24, by 2 12, by 2 6, by 2 3 3 1. If you see that 2 into 2 into 2, 2 into 2 into 2, 2 into 2 into 3. What is the possibility here? 768 should be multiplied by, there are only 2 factors for 2, one more is needed, and the prime factor 3 has occurred only once. To make it into a cube number, it should be 3 into 3, which shows that 768 should be multiplied by 2 into 3 into 3. That is, 768 should be multiplied by 18. An application question of this type can be seen on question number 4. Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm and 5 cm. How many such cuboids will be needed to form a cube? A cuboid will have length, breadth and height. It will have length, breadth and height as given. The question is, how many cuboids of this particular shape or this particular measurement should be adjusted to form a cube? The concept here is the volume of cuboid is L into B into H, which is the same as 5 into 5 into 2. This number, if you see, 50 is not a perfect cube. A cube volume is A into A into A. So, the question can be connected as, what is the least number to be multiplied so that the resulting number is a cube number? You can see that the number is 5 into 2 into 2, that is 5 2s are 10, 10 into 2 is 20, that means 20 cuboids. The volume of this 20 cuboids will match with the volume of the cube. The concept is that way, but the application is, what is the least number to be multiplied so that the particular number 50 will become a cube number. That is, 20 cuboids are required. You are thorough with the concept of a cube number as a number obtained on multiplication of a number 3 times. So what is the inverse operation of it? The inverse operation, we call it as cube root. That is, given a cube number 1331, what is the inverse process is the finding the cube root of 1331. That is the number by which 3 times you have multiplied so that you are getting the cube number 1331. The only method of finding cube root is by prime factorization. And when you are doing prime factorization, let me explain the divisibility test to make it simple. Divisibility test of 2 is the units place is even. Divisibility test for 5, units place is 0 or 5. Divisibility test for 3 is add the digits. The sum is divisible by 3. For 11, add alternate digits. Add alternate digits. Subtract the answers. The difference should be 0 or divisible by 11. I will show an example for 11, 1331. 1 plus 3 equal to 4, another 1 plus 3 equal to 4. The difference 4 minus 4 equal to 0. That is, the difference should be either 0 or a multiple of 11, or a multiple of 11 will give you the idea of divisibility by 11. Now, when you are finding the cube root of a cube number, we know that the prime factor should occur 3 times. That is, if the question is a perfect cube number, once you get any one of these factors, definitely it will occur 2 more times. This I am explaining for you because you should not waste the time in finding out the factors. Find the cube roots of question number 1 from exercise 7.2, 10,648. 10,648. I will explain how to present the answer. By 2 is 5, 5,324. by 2 is 2 2s are 4, 6 2s are 12, 6 2 divided by 2 is 1331, 11 is 121 by 11. Cube root of 10,648 is the same as cube root of 2 cubed into 11 cubed, which is the same as 2 into 11 equal to 22. You must write the steps as shown here. The most common method is cube root by prime factorization. One more method they have prescribed in your textbook as by estimation. That means they will be giving you a cube number and an estimated method. Since 1 cubed is equal to 1, 2 cubed is equal to 8, 3 cubed 27, 64, 5 cubed 125, 6 cubed 216, 7 cubed is 343, 8 cubed 512, 9 cubed is 729 and 10 cubed is equal to 1000. So it is based on looking into the units place and the number between the other places. Mainly this method is depending on looking into the units place of the cube number. Find the cube root by estimation method of 8,57,375. It's only by an estimation method. They are asking you to check. As the square root in long division method, you are separating the digits from the units place with 2 digits. We are going to take here with 3 digits. So 375 will be grouped, 857 will be grouped. That is 857 and 375. Based on the units place 5, we can understand that the units place of the cube root will have 5. Now, the number 857 is lying between 729 and it's lying between 729 and 1000, which means that the number possible for the 10th digit is either 9 or 10. The 9 cubed is 729, 10 cubed is 1000. The proximity for 857 is 729, definitely it cannot be 1000. So the estimated answer can be 95, that is cube root of 8,57,375 can be estimated as 95. First example, 17,576 divided with 3 places from the units place. 6 in the units place is giving you the ones place of the cube root number as 6. 17 is lying between 8 and 27, which shows that the cube root's tens place will be either 2 or 3, and the proximity of 17 is for 8 rather than 27, so the cube root will have the digit 2. That is, cube root of 17,576 will be 26. Similarly, 4,913, the digit 3 gives you an idea that the units place will have 7, 1 and 8. 4 lies between 1 and 8, that is between 1 and 2, and 4 will have a proximity close to 1 rather than 8. So the cube root will be 17, that is cube root of 4,913 is 17. Let's go with the approximation here. 12 and 167. 7 in the units place is giving you the ones place as 3. Since the numeral 0 to 9 occur only in 1 cube numbers, that is why this method is very applicable. 3. 12. 12 lies between 8 and 27, between 2 and 3. And 12 has close proximity to 8, which shows that the cube number is 23. That is, cube root of 12,167 is 23. 32,768. 8 in the ones place denotes you the 2 in the ones place, and 32 is lying between 27 and 64. 27 is 3 cubed and 64 is 4 cubed. The proximity of 32 is towards 27, which gives you the tens place as 3. Thus, cube root of 32,768 is 32. I hope you understood the concepts very well, and by this, the chapter 7 cube and cube root is also over.